All right, here we go. And so continuing on from that last video, we make sure you understand what's going on here, why we have the boundary at -2 and +2, because that's going to be important here for this problem. So we cannot have a squared minus b squared. It has to be a positive number. So a squared minus b squared has to be greater than or equal to 0. And this is a difference of squares, so this will also factor, and this is going to be a plus b times a minus b is greater than or equal to 0. And so I want you to again, really understand what's going on here. If we were to graph this and kind of graph our roots, and we're going to have a root at -b and at positive b. So these will be our b values, if you will. And so this is at b, this is at -b, and we'll have our kind of our parabola shape here again. And really just looking at where we have negative or positive values. So before we had 4 right here. So same idea, just now instead of being specifically -2 and 2, it's -b and b. And those came from right here. Now, it can't be negative, so again, these values are excluded, but now we can have when a is equal to at this point, because if we have 0, 0 is okay. It's no longer in our, it's no longer in a denominator. So our final answers here is when a is less than -2, or sorry, when -b, a is less than or equal to -b, or a is greater than or equal to b. So there's our domain. Actually, let me box that up. And go back. Here's the domain on that last one. And here's our domain on the previous problem as well. Okay, last problem. We've got the f of x, y, or f of x and y. You'll hear that referred to both ways. The x, y does not equal 0. Hopefully we're pretty comfortable with that, because if they're in the denominator, we can't have x or y be equal to 0, which means that, let's see here, just keep that in mind. That's probably the best way to say that for right now. We also can't have 2x be negative, so 2x has to be greater than or equal to 0, because it's in that radical, and we could end up with imaginary numbers. So divide each side by 2, and x has to be greater than or equal to 0. Now, from right here, if we were to divide both sides by y, we have x has to be, cannot be 0, because if I divide each side by y, then I'll say x is not equal to 0. Or divide each side by x, then y is not equal to 0. And kind of these two right here combined mean that our domain will be where x is just greater than 0. Remember, it can't actually equal, so even though it does say or equal to right here, it's not really in our domain. It's not a possibility. And then y doesn't equal 0 due to our restriction right here. All right, hope that helps.